Now it's a DT video structure going to be handled by the following students.
Good morning. Today I'm going to take about cement manufacture.
Speak it loud, Anna.
So basically, cement is manufactured in a pipeline where the input materials are chemically transformed into high strength binding material through three processes, namely crushing, heating, and grinding. The end goal is to achieve a consistent strength, durability, and performance. So let's look into the raw materials used. So first, limestone is added, which is calcium oxide, and in clay we use silica and aluminium. And for gypsum, we are using gypsum. We are adding it later to get the controlled setting time.
In clay, we are adding silica and aluminum oxide. Silica and aluminum oxide is the main material.
And let's look into the process of manufacturing cement. First, we are using crushing, in which cement is initiated with fine powder, and we have to make it a uniform particle size for efficient chemical process. And in mixing, we use accurately proportionated materials to ensure chemical consistency. And heating, we are heating at 1450 degrees Celsius, that is 1450 degrees Celsius. And in this heating, we get a substance called clinker. This clinker is what gets the DNA of cement. And in the next process of cooling, this hot clinker is cooled to get the stable mineral structure. And in the last process of final grinding, we get clinker and we add some gypsum to get the stability of the cement, and as a final product we get the cement. So next, in terms of calculating the grade of cement, we have three grades, namely
33, 43 and 53.
So this unit is calculated in MPa.
MPa is nothing but Newton per mm square. Megapixel. Mega. M stands for mega. And this stands for Newton per meter square. Newton per meter square. Okay?
So 33 MPa cement is used for low-rise buildings, and it is also used for plastering. So next, 43 grade is used for residential and commercial RCC, which is we commonly use for our buildings. And 53 grade is used for high-rise bridges, heavy load structures. And the most commonly used 43 MPa is most commonly used because 53 MPa is comparatively strengther but comparatively strong, but it requires strong and perfect curing. Hence, 43 grade is most commonly used.
Okay, very good.
Thank you.
Anna, please stand there.
Two main strengths, that is compressive strength and tensile strength. So compressive strength is how much a load or weight or pressure which a cement can withstand. That is when it is pressed or squeezed. Cement grades like as already said 43, 33 and 53. It is classified based on the compressive strength. So 43, for example, 43 grade cement can withstand pressure of 43 Newton per millimeter square after 28 days. So this 28 days is the duration time which is given for cement to get hardened or become more strong. So higher the grade, higher that is stronger this cement. So next comes the tensile strength. Tensile strength is how much force a cement can carry when it is pulled or stretched. So basically tensile strength is pulling forces. So cement is not good at handling pulling forces. So tensile strength is very low compared to the compressive strength. So tensile strength is nothing, that is 1/10 of the compressive strength. So because of this, cement or concrete can break when it is pulled or stretched. To solve this, steel is added to concrete. That is, concrete is strong when it is pressed. That is, concrete is good at compressive strength. Steel is strong when it is pulled. That is, it is good at tensile strength.
We use normally what steel we are using? Torsion steel or mild steel? Torsion steel is used. Torsion steel is used because of the bending process. Because of the bending process. Okay, mild steel is nothing but it is a capability of tensile load and also compressive load. Whereas the torsion test, it is used in shear stress. It is used in shear stress. Okay.
So steel is very strong when it is pulled. So when both of this is used together, it forms the term RCC, which is reinforced cement concrete. It is very stronger and usually used for constructing bridges and other bigger structures because it is very strong when the steel and the cement is used together. Thank you. Applications of cement. When cement is binding with the cement is used as a binding material. When it is mixed with the water, it holds the construction materials together. Now we see the applications of cement. Cement, where we use the cement for building materials, building construction. It is used to construct buildings like houses, schools, hospitals and offices. Construct structures. It is used in PCC and RCC for beams, columns and slabs. Main used cements are Portland, Barcelona cement and ordinary Portland cement. These are the main ordinary cements that we use. Cement plastering. The walls look smooth and because of the plastering of cement, it protects walls from rain and heat. Road constructions for railways and airport runways. Decorative works for ornamental works and for making statues, the cements are used. Hydraulic structures for construction the buildings, canals and tanks. Marine structures, airports, docks and sea walls. Precast products, cements, pipes and blocks are used using cement.
Okay, fine. She would say, what are the uses of cements? Normally, the cements are classified into two types. Normally, Portland cement and the other one is special cement. What is Portland cement? Portland cement, it stands the grade of 53 Newton per mm square. The other cement, those cements are classified as white cement and colored cement. Where we are using white cement? White cement is we are using normally for plaster of Paris, we are using white cement. And where we are using colored cement for wall coloring, we are using coloring cements. And what we are using the next cement? Extension cement. Extension cement, where we are using normally the cracks will develop. To arrest the cracks, we are using the extension cement. So these are the special cements. Okay.